This is John Black, Super Chemist. This is not an instructional video. It is just a vlog showing a video account of some chemistry experiments I have done or am learning about. I do not go over all safety concerns, so if you repeat anything in the video, you do it at your own risk. Now, if you saw my last video with the nitroethane, you'll know I need a mechanical stir instead of a magnetic stir. Because magnetic stirrers can only stir so much. They only have so much power. Anyways, here's a couple examples of or ideas I'm having about it. This is a blender when in the olden days. Now this just comes out. You can see there's two little divots to come out, and that's what makes it stick into the blender without flying out. If you can do that indentation with some pliers, get some pliers, heat this up, and just squish it so that it's like that, you know what I mean? And then squish it on this side. And if you can do it exactly the right dimensions or whatever, you can use glass. Otherwise, you're kind of stuck with this particular piece right here. And you can see it's metal and it has some plastic on the bottom of it. So the plastic might react also, with like hydrocarbon solvents, you know what I mean? Benzene or something like that might dissolve it, diethyl ether might dissolve it. DCM might dissolve it. The metal, you have to worry about acids and maybe even bases that it's going to, corrode it and react with it. But there is that something, I don't know if it's vinyl or PVC, it's a liquid. You see on this tool how on the handles it has this, like, I don't know what that is. But they do that on a lot of tools or whatever. It helps insulate it in case you get electrocuted or something. And it probably helps, if you're putting it on something hot, this thermally helps resist that heat. But they have a can that you can buy, and you just dip this into the can, right? You open the can, and there's a liquid stuff in there. You dip it in, and then you let it dry, and it'll put a coating of something on it. Maybe you could use that on this. And dip this in so that and let it dry, and maybe it won't be reactive then. Or maybe you could use, because the stir bars are coated with something there, it's coated with Teflon. You can buy Teflon paint and paint this, and coat it with Teflon paint, and that might make it not be corrosive. All right. And you can see, I don't know if you can see it, let me you can see this won't fit into the round bottom flask, but an Erlenmeyer flask goes right in there, right? Now if you can put this on here. Now see this little thing here? There's a little plastic thing. I guess you're supposed to hang your cup on it or whatever to hold it in place. You can cut that off, you know what I mean, with a hacksaw so that you can move your Erlenmeyer flask over more. But look, it does work. You can use a clamp like this over here. Clamp this up in position, and you can see, I can turn it on. And another thing is let's say you wanted to use the round bottom flask, you can't get it in close enough. You know what I mean? It's too bulky. But what you can do is this pivots back and forth, and even when it's pivoted, you can still turn it on. Now watch, let's say I had a different, I ripped this plastic thing off and I can actually get it in there. I can come over here, and you can see I have it clamped so that it's at an angle. And just put this at the angle. You can see it'll go right in there. Exactly. You can just turn it on. Okay. And you'd be able to get the round bottom flask to stir. These are nice if you can get, if you know someone that goes to garage sales, or you go to garage sales, you could probably find one of these. I don't have any Teflon paint, so I'm trying to do stuff with what I have in the house. This was my next idea. You can see I have this little cheap, it's a drill that doesn't even work. If you buy it, you're going to throw it away because it's garbage, okay? It won't unscrew anything like that. I mean, I've never used it, but I know it won't. um, but check this out. All right, I don't know if you can see inside there or not. Let me, then it got the has the gasket in here. It just barely turn. I mean, I have some resistance when I'm pulling it up and down. You know what I mean? But there is a gasket in there. See, these you have threads on there and threads on this red thing, and then the gasket's in there. And as you tighten it, it will squeeze that gasket even smaller. But it's just the perfect size for this glass rod I have. And what I did was, I started with a glass rod, right? I heated it up, and I got just a pair of pliers. And I bent over a piece, you know, about that much, bent it over, and then I heated that up, and then I just crimped it with this. Unfortunately, my pliers are really dirty and have a bunch of crap on them. I should have got some clean ones. So it made it kind of black. So I just squished it while it was hot. And you can see I have like a leaf or whatever on the bottom of this. It's kind of black because from my dirty um, pliers. Now that's even smaller than I needed. I actually would have had to flip this a second time and squeezed it so I could fan it out more. And because look, this piece here, look how much bigger it is. It's about a millimeter bigger than the glass. And this has another millimeter or two leeway when it's inside here. Just look, that's the fattest part, and look how much it moves back and forth. It's a pretty good bit. This is just for a thermometer thingy, this thing here, but it's good for hoses and for this. And basically all I did was I taped this up at just like a drill bit, right? Taped it on there with electrical tape. And you'll see on the outlet it's like for wrenches. See how it has that like benzene type, so you can put a wrench on it. These stir rods are round, but what I did was I got some of this Teflon tape, which is just plumber's tape. It's actually kind of, it's that tape that you put on your threads of plumbing stuff so that it doesn't leak out water. I got some of that, and I put it on the end of this, right? I don't know if you can see it, but this part up here, the first 4 or 5 millimeters, is hexagonal now, even though it was round to begin with, because what I did was I just smashed it in there until it went into it, and it kind of made it into a a hexagonal type thing, you know what I mean? Then this right here, I just tighten when I put it on, I tighten it up. And you can see it moves back and forth, but look at that. It'll stick if you put it in a certain spot. I mean, it's not, sometimes, see how it slips down? Sometimes that's how it is. It's good enough to slip down if I jiggle it. Now this is that stir rod with the top, remember the plastic part? And if I take the plastic part off, you'll see this black gasket here. You can see it's nice and snug. Actually, it takes some pressure, not a lot, it takes some pressure to move it up and down. So this easily turns, you know what I mean? Um, but it's still snug. And you saw when I had the weight of the glass on here, right, that you screw this to, and I wiggled it, this actually started to slide down from the weight. But you can tell, it doesn't matter how much I wiggle it, with no weight on it, it stays there in the same spot. So it has good enough leeway to be able to, move. Now, is this good enough if you're refluxing something, you know what I mean, where you have a lot of vapor in the pot? I don't know. You might have to make it longer by either weld them together with heat, a bunch of these stir rods, or just buy one long one, or a tube that can fit, but it has to be the size of your drill bit, or slightly smaller so you can, uh, put some Teflon tape on it, shove it in there, and then use some electrical tape to make sure it doesn't come out, right? And that way you can. And if you have some kind of ties, plastic ties or whatever, you can clamp this onto, say, here, so that you don't have to hold it, right? And put a twisty tie around the handle so that it just runs constantly, and then you'd have that right there. Like I said, that pin should be a lot bigger, like at least 3 milliliters, or two or 3 millimeters. It still doesn't make it that big, but the other Meyer flask, you can make it even bigger. You know what I mean? You can make it like an inch or whatever that is, an inch and a quarter, an inch and a half wide. So anyways, that's it. That's my whatever. That's it right there. So this actually, I didn't realize how snug this was. It is more, it's like really snug. Um, if you threw some Vaseline on there, maybe this would be good um, to stir stuff even under reflux conditions. I don't know. Now keep in mind, if you are refluxing, you can have this long enough to go all the way down through the um, condenser, as long as it's a regular West type condenser, or whatever you call the straight condensers. That way, as it refluxes, the condenser will condense it out, and you won't need a gasket. And your stir rods, you can basically just think of this part right here as the condenser. You know what I mean? Just enlarge it, and when your stir rod came down all the way to the bottom there, it doesn't interfere with anything. You know what I mean? Because your condenser is just a tube, just like this is a tube. If anything, it'll increase the efficiency of your condenser, because it has more for the area now for the vapor to condense onto, right? And you could still have it turning, because this is a cheap drill. It's not like, going out of control or whatever. It's just, but it's powerful. It's powerful enough to turn it doesn't matter how much solids is in there, it's going to spin. But it's not too powerful that's all the power it has, like, you know what I mean? In 8 hours, I think you might burn them out if you just constantly run them for 8 hours. Now, another idea is to buy a drill press, and you can use this to clamp on um, your round bottom flask or whatever you're going to be using as a vessel. This guy, he actually built this, so he put a clamp there. I can actually take that off, that platform there, to get it out of the way, and it would be ready for use. And then I could just plug that into you see how I have that? It's just a plug, an extension cord, right? And I wired it up. I cut the extension cord off, wired it up, so that it goes through this switch and then these plugs. Now I should have made this into a dimmer switch. That would have been even better. You know what I mean? And then I can plug the drill into here, and I can use my dimmer switch so that it's not going so fast that it's unreal or whatever. Just put a twisty tie thing around the trigger of this drill, and you can see it's stirring it up a little bit. See how I got the band on the trigger? Anyways, y'all have a great day, and always remember, science is great.